conductor that experiences a force when placed in an electromagnetic field. Electric charge generally can be either positive or negative. The presence of electrical charge in a body can be determined by the number of electrons present in a body. Once a body loses electrons, it is said to be positively charged. When a body gains electrons, it is said to be negatively charged. The charge is said to be quantized. How can you say that the charge is quantized? It can be demonstrated by using the formula Q is equal to plus or minus N into E. Here total charge on any body is always an integral multiple of basic unit of charge E. Here the plus sign indicates that the charge is to be positive, minus sign indicates that charge is said to be negative. Therefore, around any charge, there is an extent up to which its influence is manifested. The extent up to which its influence is present around a charge is called electric field. The electric field strength or electric field intensity can be defined as the force experienced by unit positive charge placed at that point. Therefore, electric field intensity or electric field strength E is equal to F by Q. It can be formulated as E is equal to F by Q. Therefore, the force experienced by unit positive charge placed at a point in an electric field is electric field intensity. E is equal to F by Q, which can also be written as 1 by 4 pi epsilon 0 into Q by R. By the way, suppose there are two charges Q1 and Q2, which may be either positive or negative or positive or negative, positive negative. The force of attraction or repulsion between these two charges can be determined by using the formula Coulomb's law. It can be understood by using the Coulomb's law. According to Coulomb's law, the force of attraction or repulsion between two charges is directly proportional to the product of the charges and is inversely proportional to the square of the distance between them. Therefore, F is proportional to Q1 into Q2. F is inversely proportional to R square. These two relations can be combined together by using F is proportional to Q1 Q2 by R square. F is equal to some constant K into Q1 Q2 by R square, where K can be taken as 1 by 4 pi epsilon 0, where epsilon 0 is the permittivity of free space or vacuum. Electrostatic potential at any point in an electric field is defined as the work done by an external agent in bringing a unit positive charge from infinity to that point in the field. It can be formulated by V is equal to 1 by 4 pi epsilon naught into Q by R, whose derivation is given as follows. By the way, the electric potential energy of a system of charges is equal to the work done in bringing the charges from infinity to form the system. For example, two charges Q1 Q2 separated by a distance small r, U is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R. The radius of the gold nucleus is 6.6 into 10 power minus 15 meters and the atomic number is 79. The electric potential at the surface of the gold nucleus is, in the given problem, 1 by 4 pi epsilon naught is equal to 9 into 10 power 9. Since the atomic number is given to be 79, Q can be taken as 79 into 1.6 into 10 power minus 19 coulombs. Therefore, radius of the gold nucleus is given to be 6.6 into 10 power minus 15 meters. On substituting all these values in this formula, V is equal to 1 by 4 pi epsilon naught into Q by R, we will get 1.7 into 10 power 7 volts. two charges plus q and minus q are 1 meter apart in air. At the midpoint, the potential is minus 256 volts. The electric field at that point is equal to. Know that electric potential at a point due to a point charge V is equal to 1 by 4 pi epsilon naught into Q by R. Let the given charges be denoted by Q1 and Q2, that is plus Q minus 9Q. Therefore, total potential V is equal to 1 by 4 pi epsilon naught into small q into Q1 by R1 plus Q2 by R2. Therefore, minus 256 is equal to 9 into 10 power 9 by 0.5 into plus q minus 9q, because 1 by 4 pi epsilon naught is equal to 9 into 10 power 9. Q1, like capital Q1 is given to be plus q and capital Q2 is given to be minus 9q. So to find out the electric potential at the midpoint is 0.5 meters. R1 is equal to R2 is equal to 0.5 meters. On simplifying it, we will get small q is equal to 32 into 0.5 by 9 into 10 power 9 coulombs. Therefore, E1 and E2 are the potentials due to plus q and minus 9q. Therefore, E1 is equal to 64 Newton per coulomb. E2 is equal to 64 into 9, 576 Newton per coulomb. Total electric field at midpoint is equal to 640. E is equal to E1 plus E2, 64 plus 576, 640 Newton per coulomb. A body of mass 1 gram and carrying a charge of 10 power minus 8 coulombs passes from 2 points P and Q. P and Q are at electric potential 600 volts and 0 volts respectively. The velocity of the body at Q is 20 meters per second. Its velocity in meters per second at P is. Mass of the body M is equal to 1 gram is equal to 10 power minus 3 kg. Charge Q is equal to 10 power minus 8 coulombs. Velocity of the body at Q, VQ is equal to 20 into 10 power minus 2 meters per second. Can be done by using the concept of work done is equal to gain in kinetic energy. Q into delta V is equal to 1 by 2 m into VQ square minus VP square. On substituting and solving, we get of the body at P is equal to root of 0.028 meter per second. Two positive charges 12 microcoulombs and 10 microcoulombs are initially separated by 10 centimeters. The work done in bringing the charges 4 centimeters closer is. Here Q1 is equal to 12 microcoulombs, Q2 is equal to 10 microcoulombs, R1 is equal to 10 centimeters, R2 is equal to 4 centimeters. On substituting all these values in the formula, W is equal to 1 by 4 pi epsilon naught Q1 Q2 into 1 by R1 minus 1 by R2, we will get work done is 17.2 joules. Here two equally charged pit balls are separated by 3 centimeters, repel each other with a force of 4 into 10 power minus 5 newtons. The charge on each pit ball is. Since the two charges are equal in magnitude, the force between them is 1 by 4 pi epsilon naught into Q square by R square. Therefore, 4 into 10 power minus 5 is equal to 9 into 10 power 9 into Q square by 3 into 10 power minus 2 whole square. On simplifying it, we will get Q square is equal to 4 into 10 power minus 18. Q is equal to, taking square root both sides, we will get 2 into 10 power minus 9 coulombs. An electron of mass 9.1 into 10 power minus 31 kg is sent into an electric field of intensity 9.1 into 10 power minus 6 Newton per coulomb. The acceleration produced is. Now that from the definition of electric field strength or electric field intensity, E is equal to F by Q, F is equal to EQ. But according to Newton's second law, F is equal to MA. Since LHS are equal, RHS can be made equal. MA is equal to EQ, A is equal to EQ by M. Therefore, 9.1 into 10 power 6 into 1.6 into 10 power minus 19 by 9.1 into 10 power minus 31. Therefore, acceleration, and simplifying it, we will get A is equal to 1.6 into 10 power 18 meter per second square. In this session, we have covered the concepts of electric potential due to a point charge, electric field intensity E, and the force between two charges using Coulomb's law, and the problems related to these concepts. If you practice all formulae along with problems in this manner, you will be achieving whatever you want to achieve.